Okay, so hopefully you can see my PowerPoint slide, my single slide. This is just literally 2 minutes, just the way that we organize these sessions. This was actually attached to another session originally, but I wanted to pull it out separately simply because it's highly relevant to multi-messenger type events. As with other brokers, of course, you can specify watch lists on the sky and areas on the sky. So in this particular case, our friends in Strasbourg have provided this. Let me just open this thing up. The MOCPI, the multi-order coverage maps, which is a way of specifying an area on the sky. And inside Lasair, you can define an area on the sky that you're interested in and initiate hits on that area of the sky. So there's the link for the multi-area coverage maps. So you can find the documentation there. And likewise, it's an IVOA standard. We are using this to specify these areas on the sky, which can be predefined. So I've not gone, if I'd have realized I had more time, I would have gone through the coverage of how you create an area. But what we've done is predefined a couple of areas. So we've just grabbed the SDSS footprint in this particular case. So it's this one here, in fact, on Lasair. Then we also happen to have a watch list, a bunch of watch lists. So randomly we chose a watch list of BLACs, some AGNs that somebody's created. So this watch list here. What I wanted to show you is this is just an SQL query, but it's a query that allows you to join. First of all, to select information from those area hits on the sky that we've hit. So anywhere in the sky that you specify where there's been an event, but especially you can also just for a laugh join your area hits with a watch list. So our watch lists are currently 1 million objects in size, up to 1 million objects in size. So you specify RN deck and association radius for up to 1 million objects. Anyway, more information on those two links. So the area and watch list links on Lasair. So as before, we do a pip install. So let's let it go and do the installation. Yeah, I can see why people don't wait for Google Colab. So I'm just waiting for that to complete. I think it has complete. Anyway, let's go and grab my token as before. So I'm just using this token, which is going to expire on Friday. I should also give you just a heads up that on Friday we have a big maintenance operation happening. So actually Lasair won't be available on Friday for the whole day. So just in case you're trying to do anything with Lasair on Friday, I'd just like you to know that we're not going to be available. It's an unavoidable upgrade to our infrastructure. So let's just import the relevant library. And then here is our query. So what we're doing here is, as with other brokers, we allow an SQL-like language. So I say SQL-like because what we've actually done here is, instead of a from statement, we have a table statement that says, okay, we're going to select against objects. This Sherlock classifications table, it just tells us whether they're AGNs or whatever. And then this kind of clumsy looking thing where we say we're actually going to match against watch list number 35 and areas number 2 that we've defined. So 35 is our BLACs and areas number 2 is our SDSS tokens, SDSS area. And in this case, I've set the condition, i.e. our where clause, to be blank. So that will effectively tell Lasair to attempt to do the joins in the background. So if you want to restrict the data further, of course, you can do that. by setting everything brighter than magnitude 15 or whatever. So let's just run that and grab the data. And this is just saying, have I actually got any data? Do I have any hits? Yes, I have a bunch of hits. So just the query is just telling us whether we think it might be near a star. Of course, the Sherlock classification has classified these as AGNs, as you would expect it to do so because they're BLX. And then the last bit is just covering what we covered yesterday, which is basically go and grab the light curves from the objects API. So there's our objects API here, and go and grab the light curves and plot them. So this is literally all I wanted to cover. By the way, we do cache the, as Ofer was mentioning earlier, we do a daily and weekly cache of the TNS. So we do our cross matches internally on the Lasair platform rather than directly against the TNS. So in this case, some of our objects have no TNS info simply because the platform doesn't contain all the data at the moment. We're in the process of building and rebuilding the platform and redeploying. So that's all I wanted to cover. And of course, the obvious overlap here is if we go back to areas, where is it? Areas. So for example, we've defined GW 170817 as an area, and we'll do this automatically anyway. We'll grab the heel picks and 90% probability regions for the LIGO, Virgo, and Cagra hits and load those up automatically, but you can define your own. For further information, contact us in Slack, and we'll be happy to answer your questions.
Great, thanks, Ken. We've got a question from Michael Udvesi on Slack. So are you trying to determine the tables you need to join based on the properties of the query? And if so, how? And why not just using a view instead?
That's a good question. So basically, we join most of our tables via the object ID. If the table join doesn't contain that kind of, if the table that we're joining to doesn't contain an object ID, we make the assumption that we use the primary key to try and join the table. Sorry, I can't remember the full question. Sorry.
So why don't you just use a view instead instead of joins?
Well, you can, but somebody has to create those views. You have to define the views, which can be done, of course. Fundamentally, there's no reason not to do so. We didn't want to limit you to the number of views available. And again, creating views creates all sorts of implications about security of our system, the load on the system. Even with a select, for example, you can do select star from objects, and these nested queries could be quite hefty load-wise on your system. So we do have some security built in to mitigate that kind of nested query type risk. But creating a view, who creates the view? We could create the view, I guess. So fundamentally, the long-winded answer to your short question is there's no reason why we couldn't use a view, except who is responsible to create it and destroy it.
Okay, thanks, Ken. So we're a bit ahead of time, so maybe I'll hand over to Anis again. Ken, you've got a couple of questions in Slack there.
Sure.
And maybe you could answer them.
Yep.
Okay. So thanks to all our tutors.